Hello everyone, this is Dr. Ali, and in this session we want to see what is the how to translate between different number systems. For a start, we want to see how to translate between decimal system to other systems. Let's see an example and things will get clear. So what is the equivalent of number 135 in decimal system to octal system? For calculating that, first we need to draw this table, which has 4 columns. The first column is the number divided by the exponent. The second column is the remainder of this division. Third column holds the digits in the octal system. And the fourth column is the different exponent of the target base, which here is 8. So at the first step, write the exponent of the target base until you reach a number higher than the source number. Okay, so a to the power of 0 is 1. So we will keep doing this comparison in order till we to the point that we see a true statement. So 1 is not greater than 135. So this is a false statement. So what we do, we go to the next step. 8 to the power of 1 is 8. Is this 8 greater than 135? No, this is false. Go to the next. 64 is greater than 135? No. 512, which is 8 to the power of 3, is greater than 135. So we stop here, and now we start to fill the rest of these rows here. Second step is proceed with the floor division and complete the rows. This double slash is called floor division. And its difference between a typical division and floor division is that in the floor division, we get rid of those fractal part of or fractional part of the this typical division. Okay, so first we do this division, then 135 divided by 512 is equal to 0. Remainder is 135, and whatever the result of this division is, we put it in the oct system or octa cell. And then next step is now the remainder goes to the next row, and we divide this remainder by 64, which is this exponent, and the result is 2. So we put this 2 in the oct column, and we calculate the remainder, which is 7. So this 7 goes to the next row. So what is the result of 7 floor division by 8 is 0. And this 0 goes to the oct column, and the remainder is 7. And the 7 goes to the next row, and the result of this calculation is 7. And the remainder is 0, and this 7 goes to the oct column. So this 207 is the equivalent of 135 in octal system. So one question here is, what is the number of required digits in the target system? Obviously, if you have this table, the number of required digits is 3, right? So it is whatever the number of these rows are, 1 less than those numbers. So for example, here we have, we used 4 different exponents, but 1 minus that, because the last row or the first row here, we don't use it because it's always 0 in equivalent, because this number is always greater than the number that we want to find its translation. So it's the case that we can always get remove or ignore this first row. So the number of digits is always 1 less than the number of rows that we have here. So let's see another example. What is the equivalent of 135 into hexadecimal system? So we do the same thing. We draw this table, but instead of octal here, we use the hexadecimal. So is it 16 to the power of 0 greater than 135? False. Is it 16 greater than 135? False. Is it 256 greater than 135? Correct. So we stop here, and now we try to fill the rest of these rows. So we proceed with the floor division and complete the rows. So 135 divided by 256 is 0. So this 0, we move it here in the hex column, and the remainder is 135. So this 135 goes to next row. what is the division of 135 by 16 is 8. So this 8 goes to the hex column. And what is this remainder? 7. 7 goes to the next row. What is the result of this division? Is 7. 7 goes to the hex column, and the remainder is 0. So 8, 7 is the result of, or the equivalent of, number 135 in the hexadecimal system. So now let's look the other way around. So it means that we want to translate from other systems to the decimal system. Let's see it through some example. For example, we want to see what is equivalent of 10001111, which is a binary system, to a decimal system. First, we need to create this table, which number of columns of this table is the same as number of digits that we have in the source number. So here we have 8 digits, and we have 8 columns here, and the header, or let's say the value for each one of the columns, is raising the base to the power of the digits index. So this is the digit index 0, this is index 1, this is index 2, and so on. So the value for this digit is 2 to the power of 0. The value for this digit is 2 to the power of 1, 2 to the power of 2, to the power of 3, and so on. So these are the values for each column. Second step is putting each digit under its corresponding exponent. So this one goes under 2 to the power of 0. This one, which is this one here, goes to the under 2 to the power of 1, and all the way to this last one that goes under the 2 to the power of 7, which is 128. And then multiply each digit by its corresponding exponent and sum them up to calculate the result. So basically it says here is 1 times 1 is 1. 1 times 2 is 2. 1 times 4 is 4. 0 times 8 is 0. 0 times 16 is 0. All the way to 1 times 128 is 128. So summation of all of these values here in the green row is 135. Let's see another example. 87 in the hexadecimal. What is its equivalent in the decimal system? So we have 2 digits, so we have a table with 2 columns. This first column has the value base to the power of index. So 16 to the power of 0, 16 to the power of 1. So this value of this column is 1. The value for the second column is 16. And then we put these digits under each one of these exponents. So 7 comes under the 6 to the power of 0, and 8 comes here. And then at the last step, we multiply each digit by its corresponding exponent and sum all the results. So 7 times 1 is 7, 8 times 16 is 128. So the result is 128 plus 7, which is 135. So we found the equivalent of 87 in hexadecimal system to decimal system, which is 135. So one question that I have for you guys is how we can translate a number from let's say hexadecimal system to octal system. Just a hint for you guys is that you can translate this number to the decimal system, which is A, and then translate this A, which is in decimal system, to hexadecimal system. You already know the both of these rules, that how do you translate from other system to decimal system and from decimal system to other system. So you should be able to, using the previous example, to solve this problem. That's it for today. Stay tuned for next session and have a great day.